Nice to meet everybody. So what we're going to talk about today is in three parts. So the first is let's talk a little bit about what we see in cyber. What are some of the other elements that are sort of conscribing to make this such a difficult problem? And then what I'm going to do is I'm going to show one of the new products that we're announcing, which is called Tigershield, which will give us this ability now to do that. And then followed by Graham Hansel, who will sort of walk us through sort of how did we do what we do inside of a graph and in combination with machine learning. And then our third session will be Michael Shaler, who will wrap it up and then tell us why Tigergraph is so incredibly unique and fantastic for this kind of a use case. Without further ado, one of the first things that I think we're all seeing today is an overwhelming sort of approach now that it's no longer little tiny problems. It's all of our problems. We're seeing ransomware. We're seeing different kinds of attacks. We're seeing ID theft that cascade into all kinds of other kinds of things like AML or securities fraud and so on. And I think what we start to see then is the numbers have gotten rather extreme. So they've moved from small amounts of payments now to big numbers, and people are paying that because they're basically locked. And what we want to do then is, again, sort of not walk through this, but let's learn now sort of how do we get out in front of this? How does a graph database specifically help us in a very unique way avoid how these things happen, and even better, stop them and track down where these things came from? The second thing that we start to see then is it's no longer just a simple person who is out clicking on somewhere where they should not. They are actually becoming far more sophisticated. They're getting in through normal transports. They're getting in through wireless access points. They're getting in through what again seem to be emails and things inside of our firewalls. And if you follow sort of this process, they've gotten very good at locking it down so that if you don't, it's no longer a threat. They actually really cause major harm. And so I think what we want to do now is in these kinds of attacks, how do we start to do that, right? So as we follow sort of this process flow for what those things are, where do we start to go from here, right? How do we now make those a reality? The second thing that what we can do now is what happens in this case, right? So when you see this persistent threat, so when it starts with what looks like a phishing email, right? So our friends here have seen these kinds of things where they come in, and then what happens is I start to see that operation. Well, they continue to look like a good citizen, and then they go through, and then they may start to use our account. They may start to do some other kinds of things. They're whether it's cryptocurrency or some of the Brazilian ones where they've actually sort of cashed out at ATMs. Being able to identify what some of these things are extremely difficult in the traceability. So not only can we not sort of detect when it happens, but even as it processes through, it's very difficult for many organizations to find out where did it go, and even worse, if I don't know where it went, how could I possibly understand now if it doesn't happen again and again, right? And so I think that becomes sort of that 1-2 punch of stopping it, identifying now where these rings are, and then what are behaviors or feature attributes, as Graham will tell us here in a minute, for what that looks like. And then how do I use a graph database, which is what Michael will really sort of tie into. Well, now that we see these use cases, right? We see cyber. We see these use cases as they connect over on the left. Cyber may be just simply the entree into our anti-money laundering. Maybe I actually want to buy cryptocurrency and launder my money where it's untraceable. Maybe I'm actually trying to get in to create a larger theft scheme across credit card or even other kinds of things, right? And then we start to see the other use cases at the bottom. So how do I manage these? Maybe I'm doing things on Amazon and I'm doing things illegally. And then ultimately, how do I prosecute? Now that's the C part, right? That's how we find it. That's what we need to do on the business side. The other portion in the middle now is how do the humans in the middle, there are hundreds of team members that are on our cyber teams or AML or these other kinds of fraud groups, and they spend lots of time and effort. And really what they're trying to do is identify this in a simple way, show visualization. Where did the root cause come from? Was it really a spam or an excessive server attack? Was it something different? And then being able to put it on a map and identify where it goes and where it went, and are there devices involved and where those IoT. So the good news is that all of us have mobile numbers, and now we have sort of this tidal wave of data, which really brings us to our third part, which is how do I act on that? And that's what Graham and Michael are going to share with us, is how do we find those patterns? How do we use things like predictions and standard machine learning and augment that with a graph to bring up the capability of finding these kinds of things? That's really what these three steps are: to see it, connect to it, and then finally act on it. And that's really what the power of the graph brings to us. Now, we have empirical evidence that when we see these kinds of activities, using a graph is more than just hand waving. It actually is something that we can demonstrably increase accuracy. We can reduce the false positives. The other big thing that we can do is we can bolt onto existing solutions. So many times you already have some sort of at transaction type of a process, but most of those are black boxes. Now with the advent of graph, we can then take those features or those signals, connect them to a graph database, and then we can start to look at where did the cyber or the malware actually occur. Is it something we've seen before? Is it an adjunct and we know how to solve it? Or is it something entirely new? The good thing about most of our hacker friends is they like to be lazy. They take bits and pieces of things, and we can trace that in a graph. Very easy to do and very straightforward. The other item is if you're a bank or you're someone who's sort of in the middle, how do you use that power against what you already have? How can you tell when these things are breached? How can you tell when things are sort of out of line, and being able to detect and, more importantly, stop those? And again, these are just the tip of the iceberg. What Graham is going to show us is that with humans in the loop, with visualization in the loop, and a graph database, we can see numbers of over 30%, and that's an extremely important number. And that's where we start to see this now. So when we put it on a curve, we lay that out, we can see that you get typically 5 to 6% for a baseline where you just start. And most of our customers today are doing that. Then you start to add even more here with the accuracy. And then what we're going to see today is bringing it together with not only a graph database, but the visualization in one place. We can see over 11%. And that's assuming that you're doing things in a powerful way today. For those who haven't really started on this journey, again, some of the numbers can be quite impressive. But the goal here is not to have impressive numbers, but to stop fraud. That's really what this is all about. Now, why should we do this now, right? I've got plenty of SQL databases and I have lots of human beings that are super smart. Why should I do this now? And the answer is this sort of more with less continues, right? The pandemic hasn't made that any better. In fact, it's put a lot of stress on that, right? Which is, how do we now take these technologies, bolt them in fast, and then start to do that? Well, then the other thing then is, if we don't do anything about this, well, it's catastrophic. That's no longer an option. Is go along or be sort of okay with what I have is a big deal. Now, what if we said we could actually do this and it would be a potentially less expensive with the kind of a platform? And that's, again, something that Tigergraph can help with, right? Is the total cost of ownership for these systems typically can bring down some of those costs, right? So that's never gone out of vogue. And then finally, this disruption is the last thing we need during sort of, these kinds of times. The businesses are winning and losing, and that's the last thing we need, right? The other thing then is if we do it. So let's say we do bolt it on and we go do it. That's immediate bottom line and top line, right? The time to market is the other big takeaway here, is that we can, and with technologies today, is we're able to do this in a much faster way. So in a matter of weeks versus months or years is really where we're going. So hopefully that's motivation, right? That really starts to do that. Well, as we start to look at how does this work in my organization? Well, at the very bottom, we're going to see sort of what the Tigergraph studio, that is something where, for those of you who are not familiar, at the end, we'll have some links on that today, which is how do I build that graph data model? How do I connect that in a system, right? But more importantly, the rest of the organization from the orange layer at the bottom for analytics, all the way up to investigation and customer facing, all the way up now to our executives. Those are all the people that have to use those use cases. They have to plug in, they have to identify where those alerts are. And then we may even look over at our customer, right? We may have to say, customer, we know we've got you on the line, but it looks like someone has gotten into your account, or where are those different elements, right? Because as those behaviors change, they may indicate to us that's not our normal customer, right? So we can actually lay that out. But the beauty of what we're going to show you today is this entire stack. And that's what Tigergraph has been designed to do is, number one, be the graph at the bottom. And again, Michael and Graham are going to talk more about that. But what I'm going to talk a little bit more about now is sort of this interrogation, this analytics, this ability now to see where those things fit in the stack for the normal business persons that are working together. Now, if you have any questions on these, certainly come to our website here, and we'll have a few slides more on that towards the end. But the point of this now is let's lean in, right? So how does this all fit together? What we see is our Tigergraph database. Again, leader in speed, performance, flexibility in the market for a reason, right? You can go out and look at our blogs and some of the things that are out there on the different types that are out there. But that's the core of where we're going here is a massive parallel architecture, the ability to have a storage engine for graph as well as a processing engine. And again, the power here is the connections or the relationships in the data are the most important thing that we see. Then what we can do is we can actually now overlay that with this solution for the business, right? Business folks are not going to know all the cool machine learning algorithms that Graham's going to talk about, but what they need to know is that they trust that those are in the background and that they are doing their job and surfacing and finding these kinds of things. So that brings us to Tigershield. What is that? Well, the goal of Tigershield now is that entire focus, right? It takes the back end of the database, it takes the front end and connects it together. And these are really sort of the punch list of things that are most impressive, right? That ability to increase the accuracy, lowering the false positives, use the technology you have today, maximize what that is and being able to do it fast. Because in the end, things change, not just government changes to what we do, but to adapt to what the situation is and what the threats are. And then really, it's a modular solution, right? Which parts do you need? Only you can find that out. And again, we'll lay out more about that here. But in the end, it's actually powered by Tigergraph, the award-winning and industry-setting engine behind all of that. And that's really what this is designed to do, is help target where cyber and other kinds of those use cases we mentioned are, and being able to stop it. Okay, so now what we're going to do is we'll walk through some of these inside of that. Now, what we see now is we see the ability for teams to work together. We see this capability now to surface, whether it's in the first screen at the top, connections of information, or if it is then the manifestation of malware or other kinds of software. They're both graphs, right? So what we see now is this connection or the relationship, whether it's from an IP address or a MAC address to a user, or all the way down to different parts or pieces of what may be contained in the malware. And the goal here is to be able to identify how those pieces fit together so that, again, the human can take action. We can see simple ways of doing that. Certain people see things in that sort of ball and stick metaphor, or they can see it in a different way. In this case, I see that there's a warning. I should reject this. It looks fraudulent. It appears that I have suspicious signals. And again, Graham and Michael are going to talk about sort of what's going on behind that. But in the business user, it's simple. It's easy. I see that there is something, I should react to it. Even more importantly, there is something I don't need to react to that the system has decided. And that accuracy is really sort of what we're looking for here. The other thing that we can do now is we can see things in a very different way. We can lay them out in a timeline. Maybe we can see where things were going along just fine. And as you see here now, we see that some of these things are in correlation to other things in a timeline, right? Time is very, very important in how we lay that out. And what we may realize then is, aha, I can see it here. There is a problem. There were certain things that should not have been there, and it's very easy for that person to identify. So whether it's time or different kinds of events in time. And then our final one is geospatial. Not all things are quickly identified in other ways. Sometimes it's locations. How could Scott be in two locations at the same time doing similar things? Well, that's just not a way that Scott can be in those two different places. So again, we're able to surface what those things look like in a very simplistic way. And then finally, we can connect all of the dots. You've heard the statement, connect the dots. Well, that's really what we're doing now, is that ability to bring it all together, being able to have investigators perhaps at a lower level or at a level 1, they can see the parts that they need to see, but then you can really start to dig in. And this is where we traditionally see graph user interfaces, right? But what you've seen now is they're all connected to the same graph, and that's one of the reasons why this is so incredibly powerful. Okay, so with that, what I'd like to do now is I'll actually switch over here, and then let's take a day in the life. So in our current scenario, what I'm going to be is I'm going to be playing the role of an investigator. In this case, I may actually have a dashboard. And what you can notice here is that I can see some KPIs. And again, those KPIs are all connected to the Tigergraph backend, as well as I start to see some alerts. Many times what alerts are designed by different kinds of investigators, where maybe in business terms, I want to look for things that are notable, and then I want the human to take action. And again, the whole purpose of this dashboard, as we saw that top to bottom, was that business persons, and then as I go down towards the more technical side, I can start to see behind that. But in this case, I can see some recommendations. I can also see news. I can see what kinds of things are going on out there. I can also see people. Right? All of these are behind the scenes in the graph, but in this particular dashboard, I'm simplifying it for my user. First thing that I can do then is I see an alert. Well, guess what? It looks like we're being attacked. Perhaps it's a denial attack, or it's basically overwhelming the server. I can now see that each of these different emails is going in different places. Right? I'm able to see what that account is. I can see where those things are going in a very simplistic way. Right? What I want to do now is, where am I drawn? Well, I can see now that I'm being drawn to the center, which is this host here. And now what I can start to see in the upper right is I can see risk. I can see things that are color coded that are risky. Well, I can also see that I have run a risk algorithm, and that's something that Graham will talk to us about here. But in this case, as a lay user, I can see that, well, that's obviously very risky. I can see that that risk is now taken connections here with lots of cohorts around it. So there are more than 1 or 2 neighbors. There is a betweenness, which means that maybe there is a connection to people that are problematic, or they have a secondary set of risk, et cetera. And again, these algorithms are designed in such a way to start to show tendencies, taking those machine learning elements, et cetera, and then being able to suggest to the human that this is a problem. Well, now that I've seen this the first time, maybe I, as the investigator, would like to set up an alert. So show me if this happens again, or show me if there are granular elements about what I'm finding that I want to keep an eye on, and then perhaps alert me immediately for what those things are. So what I want to do now is I want to come down here and I want to create my own alert. Now, alerts can be anything, right? They can be any set of anomaly. We can use boolean logic, but the real sort of crux of this that Graham will show us is using boolean logic with a graph algorithm, and specifically what Tigergraph can bring to us, in addition to maybe traditional machine learning that you may already have. And the goal here now is that ability to connect those. And I can set up some different elements here, again, sort of straightforward. Then what I can start to do is show me what this trigger looks like. Right? I want to come through here. I want to connect it to certain kinds of accounts or MAC IDs, and then I want to give it some Boolean math. Right? What I'm doing now is I'm saying, if this happens again on this particular server, and I'm running this 10-degree association in the graph connection, now what I can start to do is actually build this. Right? I can start to say, show me what these other elements look like and in connections behind that, right? So what I'm doing now is I'm building up what we call a predicate inside of this. Then what I want to do is now I want to weight those things. So if I find something when I'm connecting the entity data, or if I have similarity or a page rank or geography, right? Now what I can do is I can start to say, where is that risk? How do I want to modify that so that I don't get too many alerts, but I get the right alerts, right? And so that's really what I'm doing here. Then what I can do is I can go to, now what I want to do is I want to take an action. I want to create a dashboard. I want to create a queue. I want it to be grouped by, and then I can actually get a human process in here. So I want to report it. I want to have some workflows where humans are actually bifurcating what's going on here. So maybe I have a different team for what those different elements are, so that now that I can actually get on top of that in a quicker way. And then I can go validate those triggers, right? So let's make sure that I know what those are doing. And then before I get this out there, I can get it ready. Now what I've done is I fast forwarded, I get my new batch of information in real time perhaps. And now what I see is this finds the whole path for me. So I see the host, I see the email, and I see in this particular case, Fran Farmington actually has a penetration. What he's been able to do now is they've gotten in and there are some anomalies. I see that there are systems that have been accessed. I can see that there are notes now in his account to go do this. So what I'm doing now is, again, I'm viewing what that tree looks like. Well, now perhaps I want to go view his timeline. Well, what happened is sure enough, if you look at this one down here, he was actually out on vacation. But I see somebody tried to penetrate. They did do that, and then they started doing other kinds of things in other systems. So what's happened now is I followed the trail all the way in from what looked like a spam attack on some accounts, but now they're in his account. So they're doing some things that are actually what they should not be doing, obviously, to be able to do that. Now, I've been able to find that in a graph. Now, the other thing that I can do is basically what I can do now is I can switch over to another screen. Now I can say, where did it come from and what was the source of that? And now I'm looking at a second graph. And that's the other thing that Tigergraph can do, something called multigraph, which is I can have a graph of people, I can have a graph of connections and servers. And now what I can do is I can actually have my own set of data around how these attacks happen. So what I see now is a very similar style graph, but in this case, what I can say is this file came in, it was actually connecting to other places. It was actually going back outside and connecting. And then what I can do now is I can say, well, this particular one is of a type that we are aware of. So the team now at our organization actually has the ability to do this, but there are some new things that we're seeing, right? It was running a file execution. It was copying itself in a different way. And then it was starting to do some things inside of our organization that were very, very bad, right? And so what you've seen now, hopefully in this sort of quick scenario, is that the graph is extremely powerful. We can follow it all the way down through the rabbit hole into where are those things. And then I can come back now and I can start to look for attachments and then work with those things up front. So hopefully that's been insightful. All right. So now let's learn how we did it. And so with that, what I'll do is I'll pass the baton over to Graham.
Thanks, Scott. I'm going to take you on a little bit of a deep dive into a couple of methods we use and talk through some of the techniques you just saw in Scott's demo. Before we get into the specifics of the individual use cases, let me just show you two slides here related to what algorithms we're looking at from a high level, so you can look these up online if they're of interest to you. Left-hand side is graph algorithms, right-hand side is machine learning algorithms. And we use combinations of these two things by integrating the actual graph outputs into machine learning algorithms on the back end of Tigershield. And let's step ahead one slide so we can look at the individual types of graph algorithms that we use. Now, these are not algorithms themselves, but these describe the methods that we use in each of the algorithms. And you can see things you would expect in a cybersecurity analysis. Typically, human beings are doing this analysis, but using graph technology, we can automate that stuff, make it quantitative. So things like clustering, right? You want to find clusters of anomalous behavior. Things like similarity. We knew this was an attack. Is this similar to that behavior? And of course, things like path-based algorithms, where you have a known attack vector and you want to see where it came from or where it's headed and what the blast radius of that attack could potentially be. So let me show you what the architecture looks like from a logical level. Here we have the Tigershield solution just described by its layers, data coming in on the left, going through some ETL processes and MDM, and then going into what I'll be talking about today, which is the analytics detection methodologies, and then out to the user interface on the right-hand side, which you just saw Scott talk through. If we click ahead one, we'll just see a first little couple notes here. I think I just have 2 slides on what the data looks like at a cartoon level. And if you're interested in this stuff, just shoot me an email. I can connect you to somebody to talk through the details of your individual data schema. This is the type of information that we ingest into this system. It is all useful, but not all necessary. We can start with less than this if that's what you have. It's things you would expect, like user-to-user relationships or session-to-session relationships, more volumetrically. Clickstream data, server logs, all the things that you would expect in a cybersecurity solution, and I'm sure you're already collecting in-house today. More specifically, let's take a look now at an individual schema here. This is just a cartoon drawing out the aspects of a graph schema for cybersecurity detection in at a logical level. So we can see users, we can see admins, we can see emails and organizational descriptions. And then of course we can see actual hardware monitoring metrics and logs themselves. This is what, this is kind of the scenario that we are shooting for so that we can describe the business challenge of detecting intrusions and surfacing alerts using this graph-based model. And again, at the lowest level, there are a lot more details that go into each one of the cartoon nodes you see in this diagram, and be happy to talk through that stuff if you'd like to reach out. So I'm going to move on here, and we're going to talk about this part of the model now, which is the actual analytics, the detection, and the containment of attacks. So to start off with, as I mentioned, we'll talk through a couple of different types of methods we use. To start off with, let's look at behavioral analysis. This is one of the best ways that you can use graph structured data. And it's the best because when you're describing your vectors in this case, or your entities in any case, you can see their connections to other entities or other vectors or other systems. And it's those connections which describe the behavior quantitatively. So if you trace through those, what we call edges, you can actually figure out, you can pattern match to find behaviors, and then you can go and match against known behaviors that are fraud or cybersecurity intrusions to be able to detect unknown attacks here to date. And you see the data flow there through the bottom cartoon where we have an endpoint moving a file into a server, and then there's a rule triggered, and that file actually disperses into the system. We can trace that behavior and find other behavior that's like that using graph-based behavioral analytics. And we showed some of those algorithms earlier. For the next example, I want to talk about the actual tracing of those attacks. So I apologize for putting some code out there on the slide. I know that's bad practice for a talk, but I think it's important in this case, because this is the way that you actually express yourself in Tigergraph's GSQL language. It's pretty visual, as you can see. You start at X, which is, again, like the malicious code injection, and you actually step through this path that we see described by E2 and Y, E3, and on and on and on until you get to the type of user that you are worried about being affected, right? So maybe that's endpoints, maybe it's servers, maybe it's some subsystem. And that description there, that piece of a query we see in code there, is the actual mechanism. It's the actual type that you would type down into the GSQL editor to trace out that attack vector as it moves through the system. So pretty expressive stuff there. And again, another example of why graph is really good in this case. The next one is a blast radius calculation. That's what I mentioned earlier when we were looking at that schema. The blast radius is the notion of how many systems are affected or could be affected, more interestingly, by the potential attack vector, or unfortunately, an existing attack vector that's happened historically. So what we see here is a page ranked graph, a subgraph out of a network graph, where each one of the nodes is a station in the network. The edges, of course, are communication between nodes, and then the size of those nodes is the relative connectedness to other things on the network. So what you can do is you can just make an outreach score, essentially, that says, for the big nodes, there's a big problem. Like those big nodes can talk to a lot of other stuff on the network. So you want to really heavily secure those things. And then vice versa for the smaller nodes. So that's pretty cool. Another example of graph algorithm. And in the anomaly detection space, though there are a lot of mechanisms for accomplishing this, and we'll talk through 3 more here in a minute, this is what it looks like when you actually perform this detection on the front end, right? So we would expose this to the front end. If we were serving users who were used to looking at a graph structure, like you'd see on the right-hand side of this UI, we would actually expose those anomalies as a piece of graph structured information. And then potentially your analysts are used to looking at charts or just tabular data, as you see there on the slide. And in that case, we would expose that type of information to them. And you can detect, this sort of sky's the limit here, of course, footprinting detection, phishing, all these types of attacks. You can actually surface using anomaly detection methods that use standard machine learning technology, but just ingest that graph structured information on the back end. So let's look at a cartoon example next. This is the sort of, hand-built clustered cartoon version of a graph structured piece of information. And I'm showing this before I show the real example, just to show that if you cluster your graph, it becomes really obvious, where this isn't true in relational data, but in graph data, it's really obvious what the connections are there between the people. So in each subgroup. So in our case, it would be endpoints, or it would be servers, something like that. What you're able to do, of course, is select out those groups and then do further analysis for contamination or attacks inside of each group. So I actually, on the next slide, have a quick subgraph here. We can look at an isolated subgraph inside of a network. Those node names, I assume, are the server names. And what we're looking at is as I mentioned on the last slide, connections between each one of those colored nodes. So like the yellow group, the purple group. We're looking at the so-called topology metrics, which really just means the shape of the graph. And the shape of that subgraph of those colored nodes with their connected edges is indicative of behavior, right? So when we do this clustering, and then when we do this anomaly detection, it becomes really obvious which groups are reasonable and what we expect on the network, and which ones aren't. And then for the final anomaly detection example, what I have here on the left-hand slide is just, this is real data. This is just the unstructured graph on the left-hand side. And after some graph clustering has gone on, this one was actually in conjunction with a standard machine learning clustering algorithm, you can see those neighborhoods, as clusters, as groups, just come to life. They just pop out of the graph. And the analysis of those things using the GSQL language is quite simple to select those out and see what's going on inside of each community. So that's a couple examples for anomaly detection. And let's move on now to the actual proactive case, right? So this is, the proactive posture, whereas maybe anomaly detection is only working on historical data. Maybe that's, just more like the reactive posture. We can actually use predictive analytics on top of that graph structure to be able to understand what is about to happen, not what has already happened. There's a talk we gave recently, you see there, you can find it on the Tigergraph website or on the Expero website, where you can look at the actual technical details of finding those features. And then the right-hand side is another methodology we use called dimensionality reduction. In that case, graph embedding to inject graph information into our machine learning algorithm. So let me show you what that looks like. This is high level here. This is not an individual use case. This is a description of how you combine graph with machine learning sort of generally. you start on the right-hand side there with that clustered up graph, and you extract an ego graph, like a subgraph that contains the entity that you're interested in analyzing, or maybe that's already been surfaced by one of those anomaly detection algorithms we mentioned before. And you inject that subgraph or multiple subgraphs into a so-called feature vector on the left. And that is what all machine learning algorithms are fed. The beauty of that, of course, is that you can use any algorithm you already have in-house. But the benefit of that is that you can also use that feature vector in conjunction with the subgraph above and put that into specialized graph machine learning algorithm. So either one works. And then, of course, you would output those recommendations, predictions to the UI that you see there in the bottom. So I'll show you an example of this. This is the next slide is the actual example of a TensorFlow. This is a TensorBoard output. So this is an actual neural network, graph neural network that's running on real data. We see the subgraph on the left-hand side. And then we see that information being collapsed and fed into this is a neural network for those who aren't familiar with TensorBoard. And that information you see in the upper right-hand box is then, the information flows to that computation graph, and the output is fed into some UI. In this case, it's just a cheap Excel graph, but that UI, of course, as you saw Scott show, is usually a beautiful front end. And as you saw in our case with Tigershield, that is in that React front end. So let me show you how that works in the Tigershield setting. This is a bit of a more detailed, realistic, logical look at what that Tigergraph system looks like, that Tigershield system looks like, rather. We ingest all the data you see at the top into a set of standard databases, or perhaps they're coming in through services. Some of these things we pull out to services in real time. And that information is ingested into Tigergraph, and it's fed into a variety of scoring mechanisms. So you see things like machine learning, you see things like graph algorithms. We talked about all that stuff in the previous slides. But the thing we didn't talk about is the middle one, boolean logic, which can indeed, and typically is, the business rules you already have in-house. So if you have a rules engine, we can feed it the information as well. And the reason that we do that in those sort of 3 different steps is that we combine all of the rules and the algorithms into one composite risk score, which is a sort of hybrid learned model then that showcases what we recommend as the first thing to investigate, as Scott showed, or the biggest anomaly, or the biggest potential blast radius, like we talked about before. The bottom there we see is the UI Scott showed, the human in the loop components there, where we have analysts, users looking at those recommendations and telling us whether or not the system made accurate judgments or not. And so that system improves over time. It actually adapts and gets smarter over time based on the expert user feedback. So to wrap it up, let me talk through the sort of 4 components here that we discussed outside of the algorithm space. This is the modern stack for cybersecurity threat detection and prevention. We have monitoring, which is system monitoring, and it is also model monitoring, like the outputs from your detection system. There is the capability to get new systems up and running in real time using graph-based CI/CD tools, machine learning CI/CD tools. There's active learning, which is what we just talked about, the input by users, that ability to upgrade the system, make that system become smarter and smarter and adapt to changing business rules. And finally, the interpretability characteristics that you saw in the demo Scott gave earlier, where there's actually explainable AI in that front end that allows analysts, users to understand why the system is making those judgments that it's making. And again, if you have questions on this stuff, especially, you can visit that webpage there, or again, feel free to email me. I'd be happy to talk through this stuff. So with that, I'm going to turn it over to Michael Shaler.
Very good. Thank you, Graham. I appreciate it. If you could be the slide advancer, that'd be awesome. So thank you. My name is Michael Shaler. I work for Tigergraph, and we're so delighted to be here to talk with Expero. Graham's insights are powerful, and I think that we're going to be able to talk about what underlies those from a platform perspective in greater detail. So let's talk about kind of like how to build a better cyber fraud app, and talk about Tigergraph itself. Make sure we're all clear on that. Next slide, please. Okay, so great. So Tigergraph is recognized as a leader in graph analytics, and we are in a really fast growing market. We're seeing customers embrace this for lots of use cases. We're so excited to have such great customers as Wish and Open Corporates and Intuit and others. We were founded in 2012. We've been in stealth mode. We have a large cadre of customers in production now. And underlying all this, connecting the dots between what Scott was showing earlier and what Graham was showing is GSQL. It's our SQL-like language that enables us to run graph algorithms in the graph database, and it makes our graph database the best home for AI and ML. Summary is, we answer the best questions about connected data with fast, deep, and wide insights. I'm really excited to be able to help customers in such an important place as cyber fraud. Next slide, please. So we see this, this is like the OODA loop. See, connect, act is kind of how we look at cyber fraud, and the action part is the most important part, because we can actually take a much stronger stance towards cyber fraud than we can in other methodologies, given the fact that we can see into it, we can connect with it, and then we can take action. Next slide, please. Okay, so Tigershield is, as Scott said, is all about increasing accuracy, decreasing false positives. Think about how many false positives send your operations team into every rat hole and every tailspin that you could imagine. If we can actually decrease false positives, increase accuracy, that means we can use our current technology and we can be more efficient. And then we can adapt to the legislative landscape as it continues to evolve. It's a modular total solution, and it's powered by Tigergraph with Expero. Next slide, please. Gartner has said that graph relates everything. And again, we are able to span all these technology trends to deliver very powerful solutions. Let's double click on some of those solutions more generally, and then we'll turn back to cyber itself. Next slide, please. Okay, let's go ahead and click. We connect all the data, we bring it into a distributed graph database, click. We also support advanced analytics, click, and that helps us learn. And that kind of corresponds cleanly to the See, Connect, Act framework we're talking about today. But let's go to the next slide and drill down a little bit further, please. So we have the ability then to build the enriched advanced persistent threat forensics graph. We're able to connect that with external data sources as well as external applications, but then we're able to connect deeper with the human exploratory learning. And that's where our hunter persona really comes to the fore. And then in the background, what Graham just talked about was a lot of unsupervised learning that helps deepen our understandings and raise to the front non-obvious connections that can help us predict where things are going and then take action ahead of the anomalies. And then finally, we can take action based on being able to see beyond around the corner. We can actually then start to extract forensic graph features. We can gather training data, and we can optimize operations and decisions around that. Click. Why do the traditional, next slide, please. There we go, thanks. Why do traditional approaches not work? Well, it's been a long time since we heard antivirus is dead, and that proves that when you have simple virus signatures or other approaches to, we're not addressing where things have moved from a ransomware perspective, where things are moving from a advanced persistent threat perspective. We don't want to ever see SolarWinds again. And one of the challenges, not only is our traditional approaches not working, but they make us, functionally blind. And that is scary, that large organizations with so much at risk are flying blind in an environment that has dramatically changed. Now, with all due respect to Graham, yes, AI and ML helps, but the best place for AI and ML to do its best work is in a graph database. A connected data foundation ties together so much and amplifies the effectiveness of the approach. So Scott talked about how much we can improve. We were talking about 30% on top of 60%, how much more we can do. And we can help our teams actually start to take a different posture towards how they're approaching these huge problems in large organizations. So we can help large and small, we can help go deep, and we can help teams be more effective. So let's just talk, next slide, please, about how graph analytics help. It's all about the connected data, emails, identities, accesses, hacks, and payouts. It's about connected behavior, not just user behavior, but it's user interactions. And so we can actually go deep and broad into the forensics and analytics around that. And then finally, the connected insights drive action. We have real-time insights into how we keep customers and customers of customers safe. So we really are going to be able to advance this state of the art here. One of the keys here, next slide, please. One of the keys is how we can scale to embrace lots of different kinds of data types from multiple sources. And it's not just in terms of big data sets, but also how we can do execute queries and algorithms at scale in parallel, so it scales with size. And Tigergraph has some unique capabilities in this regard that drive a considerable amount of power in ways that we don't see in other platforms. Connected data delivers connected insights, which can take connected action. Next slide, please. We can go into real-time deep exploration. Again, keeping humans in the loop is immensely valuable, but giving them every head start and advantage that your operational teams can take and with their problem set is very powerful. So we want to make sure that we have the graph insights plus AI and ML plus humans loop with this real-time deep exploration. That is a very powerful feature of this of Tigershield. So click next slide. Being able to support in database graph analytics with graph algorithms and engine support is a very powerful thing. You see in the lower right, PageRank is a very computationally challenging algorithm to identify key influencers, whether those are influencing behaviors or influencing users, or being able to do that right in terms of our language in graph database capabilities is so far unique with our platform. Next slide, please. We have 4 key differentiating features that help us with Tigershield. First of all, we have this real-time deep link querying. Being able to trace a ring of cyber criminals is a much harder task, and you cannot get it done without this deep link querying. Being able to trace 5, 10 hops, 5 degrees of separation, 10 degrees of separation, that has a very powerful capability and unique benefits in terms of being able to uncovering hard to find patterns, doing transactions and analytics, and you need scale and you need depth in terms of being able to go broad and deep to integrate all your data, different data types, different data sources, provide for automatic partitioning. You have a single logical cluster that you can speak to, and that simplifies all of the operational considerations, the app dev considerations, and this toolkit is meant to be extended, but it comes out of the box as a full solution. Tigershield also takes advantage of the in-database analytics and machine learning. And then finally, we have such great visuals and capabilities, but we also have the ability to do no-code migration from relational databases, and we have a visual query builder. Again, our goal in all this is to democratize self-service analytics and help spread the power of what we can do from a graph analytics perspective to drive Tigershield as a solution to solve the hardest cyber problems that are out there. One last slide. We're click. Okay, there you go. So Tigergraph Cloud is where you can get started. The Tigershield is native to cloud, and we can run it there. We can run anywhere where the customer needs. It can be on-prem, air-gapped, or in the cloud, and we can still take advantage of all of the capabilities and all the functionality and deliver the solution where the customer needs it. Next slide. Where to get started? We have our website, we have starter kits, and we have a fraud toolkit as well at tigergraph.com/toolkits. Expero has a great website. They actually have a fantastic portfolio and all the demos that you can access there. And specifically, you can access the fraud toolkit at that URL in the lower right corner. Very, very compelling story, and we're so pleased to be able to offer Tigershield as a way to solve for a broad range of problems that go very deep around cybersecurity and the rest. So with that, we'll now go back to questions and hand it back to our host, Laura, please.
Yeah, thanks guys for the presentations. We did have a couple questions come in, and just as a reminder, if you have any while we do Q&A, just put them in the Q&A box at the bottom of the screen. Michael, I'll start with you, but basically somebody asked, how can we get started with Tigergraph?
Well, so first place to go is to go to the fraud toolkit. You can go either to tigergraph.com/toolkit, or you can go to the fraud toolkit on the Expero website, identical, and you can get started. You can actually dig into the key capabilities of the solution, but also you can start to experiment with kind of how would this look in your environment? What data sets would you want to bring in? And then you can go ahead and reach out, and we can get on a call to talk about where it works best to deploy, if that's cloud or on-prem or air-gapped, and then how we can actually start to better understand what your needs are and how we can support your use case. So start at the website and then reach out to us as well, please.
Thank you, Michael. Graham, there was one that came through during your talk as well. Can these algorithms work for cybercrimes? And what kinds of data and SAP would I need to get started?
Yeah, they do work for cybercrimes. And the idea is that as Michael discussed earlier, some of these algorithms are unsupervised. They just work right on the data you have. And some are supervised. So if you have labels, if you have examples of cybercrimes that have been committed and preserved in your data sources, that's hugely valuable to us. So the description of those events is something that would likely be in SAP. And then, of course, the logs from servers and network traffic, that's hugely valuable. Depending on what you have, we can help you enable various algorithms, and just reach out, and I'd be happy to talk through some of the details.
Cool, thank you, Graham. And then Scott, you had one during your talk as well. How do the visuals connect with Tigergraph and other cybercrime and fraud detection systems we use internally?
So the way the system is written, somebody had mentioned it earlier, which is it's a single page application layer written in React. Inside of the Tigergraph Studio, when you write a query, there is an exposure to a REST endpoint. So we consume those REST endpoints in JSON. The other element is it is capable of connecting to any other system via those same kinds of endpoints. So we use what we call a predicate, where I may query an existing SQL system, allow that input to say, tell me all the things about Scott Heath, and then I will query the Tigergraph. And we do all that again through that REST endpoint. And it's very easy to do, and it comes in sort of one bundle, and it can be on the cloud or on premise, both.
Great. Well, those were all the questions I saw come through. Just as a reminder, we did record today's session, so I will send out an email tomorrow or Monday with a copy. It'll also be hosted on both of our websites. Feel free to reach out if you have any questions. With that, we'll go ahead and end today's session. Hope you have a great rest of your week and a great weekend.